Welcome to Promise International Online Teaching. In our online classroom today, we shall be studying the subjects mathematics and the topic is trigonometry. We're going to break this subject into three. One, look at the meaning. Two, we're going to derive formulas. And three, we're going to solve problems relating to trigonometry. Now, what is trigonometry all about? Trigonometry simply means three-sided measurement, and trigonometry is a branch of mathematics actually under geometry that is with triangles or any form of three-sided shape, three angles, three sides. We have different types of triangle. Triangles based on shape, triangles based on sides. Triangle based on the side, we have equilateral triangle, which is triangle that all the sides are equal. We have isosceles triangle, which is the type of triangle that has two equal sides and the base angles are equal. And we have a scaling triangle that has no equal side and no equal angle. Then, triangle based on the type of angle they have, we have the acute angle to triangle, we have the obtuse angle to triangle, and the right angle to triangle. But under trigonometry, the basic aspect we'll be looking at today is the right angled triangle. The right angled triangle is a triangle that has one right angle in it. That is an angle formed at a perpendicular where a vertical and a horizontal lines met. It has three sides, and the three sides are given special names. And these names depend on the angle they are facing. For example, the side that faces the right angle is called the hypotenuse. The side, should we have our angle here, the side facing our angle is called the opposite. And the side beside the very angle we are dealing with is called the adjacent. Before we move further, we need to consider Pythagoras' theorem, as that will help us to solve problems in trigonometry. According to Pythagoras, in his theorem on right angle triangle, he stated that the square on the hypotenuse is equal to the sum of squares on the other two sides. It's already proven that hypotenuse squared is equals to opposite squared plus adjacent squared. Take note of this. Let's call this equation 1. We are going to make use of this in deriving other formulas. So let's look at the comparison of the sides of a right angle triangle, which is referred to as trigonometric ratios. When we talk about trigonometric ratios, we're talking about the comparison of the sides of a right angle triangle. And the first one is sine. Sine is expressed in terms of the angle, theta. And this is given as the opposite over the hypotenuse. And the second one is cosine. Cosine is expressed as adjacent over hypotenuse. And we write this as COS, that's cos theta, is adjacent over hypotenuse. The third one is tangent. Tangent is given as tan theta, TAN, which is the opposite over the adjacent. Opposite over the adjacent. When you compare opposite and adjacent, you make use of tan theta. To help students remember these trigonometric ratios, we make an acronym from the first letters that form the formula, which is sine theta is equal to opposite over hypotenuse. So we take SOH. Cos theta is adjacent to hypotenuse, so we take CAH. Tan theta equals to opposite over adjacent, which is taken as TOA. And so we pronounce it as SOHCAHTOA. This will help you to remember that the formula for finding the sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, tangent of an angle is opposite over adjacent. Now, we have what we call special angles. When we want to solve problems relating to special angles, we don't need calculator, we don't need textbook, we don't need any aid or tables. They can easily be obtained without tables. That's why we call them special angles. These special angles are angle 0 degrees and 90 degrees complementary, 60 degrees and 30 degrees, and 45 degrees and 45 degrees. Beginning with 0 degrees and 90 degrees. Supposing you are given a Cartesian plane of this nature, here is minus x, here is x, minus y, the point where they met, 0 our origin. And we expect that our angle should run from here, from this point to the y-axis. Whatever angle we have there, we can call it our theta. Now, we want to get sine 0 degrees. Should we give from here to this point, or any point upwards, should we give from here to here the value of 1 unit? We have that, and then from here to this point, the value of 1 unit. We have that. Opposite sine 0 degrees, opposite over hypotenuse. From here to here is 0. So this will give us 0 because the distance from here to here is 0. They said the angle is 0. If the angle is 0, if the angle opens to 20, 30, 40, then the length of the size here increases. But since the angle is 0, that means the size here is 0. And so we have 0 value over the hypotenuse, which is 1. And so sine 0 is 0. Then cos 0 degrees. Cos 0, if the angle is 0, meaning this line is exactly here, then adjacent over the hypotenuse will give us 1 over 1, which is 1. then tan 0 degrees, which is opposite over adjacent, and that opposite is still 0 because there is no expanse between this line of hypotenuse and this line of adjacent. So we have that tan 0 degrees is 0. Tan 0 degrees is 0 over 1, which is 0. Now, if we want to get for 90 degrees, the values for 90 degrees, sine 90 degrees. Sine 90 degrees. Now, by the time we get a right angle here, that means from here to here, this line of our hypotenuse is standing upright. It's vertical now. So from here to here becomes 1. From here to whatever angle we are going to have here will become 0. Because this line, as it moves toward here, this vertical line tends toward the y-axis. As it tends toward the y-axis, it gets to a point here, vertically here, making it 0. And this line has also risen to 1. So sine 90 degrees becomes 1 over 1 because our opposite has also become 1. And our hypotenuse is 1, giving us that sine 90 degrees is 1. Then cos 90 degrees. Our adjacent, by the time this hypotenuse gets to the y-axis, our adjacent becomes 0 over 1, which is 0. Then tan 90 degrees. Tan 90 degrees is opposite over hypotenuse. By the time this line of hypotenuse gets to the y-axis, our opposite becomes 1 and our adjacent becomes 0. And whenever you have 1 over 0, it's referred to as infinity. So we have tan 90 degrees to the infinity. You can check it in your calculator. So you press tan 90 degrees, it will give you math error telling you that it's infinity, no specific value for it. Now, these are the values of 0 degrees and 90 degrees for sine, cosine, and tangent. Now we're going to derive the value for 60 degrees and 30 degrees. Or rather, the formula for 90 degrees and 60 degrees. 60 degrees and 30 degrees. Now, for 60 degrees and 30 degrees, we derive their values from a right-angled triangle. We derive the values from a right-angled triangle formed from an equilateral triangle. Equilateral triangle, a triangle that all the sides are equal, all the included angles are 60 degrees. Now, if this right-angled triangle, I assign to the sides 2 units and bisect the vertical angle perpendicular to meet the base perpendicularly. Here will become 30, here will become 30, here is still 60, here is still 60. This perpendicular line also bisect the base so that from here to here being 2, here becomes 1 and here becomes 1. Here is still 2. I can bring one of the triangles out. Where here is 60 degrees, 30 degrees, right angle, 2, 1. To find this, I will make use of the Pythagoras theorem. Pythagoras theorem, should I assign here the value h? Pythagoras theorem states that the square on the hypotenuse is equal to the sum of squares on the other 2 sides. So that 2 squared is equals to 1 squared plus h squared. And this will give us 4 equals to 1 plus h squared. 1 comes over here. 4 minus 1 gives us h squared. 4 minus 1 is 3 h squared. Square cross hypothesis becomes the square root of 3 equals to h, which is what we are looking for. So we now know that this triangle here becomes root 3. Now, having a triangle of this nature, 60 degrees, right angle root 3, and here to 1. (30°), right angle 2 root 3 1. Now let me start with this. Sine 60 cos 60 tan 60. Sine 60 degrees. Remember, sine is equals to opposite over hypotenuse. This is the side facing 60 degrees, opposite over hypotenuse, which is root 3 over 2. Cos 60 degrees, which is adjacent over hypotenuse, 1 over 2. Tan 60 degrees, which is tan 60 degrees, which is opposite over hypotenuse, and that is root 3 over 1, which is root 3. Now, for this, sine 30 degrees, this is the angle we are dealing with. This is the opposite. Sine is opposite over hypotenuse. So we say 1 opposite. Hypotenuse is the side facing the right angle, which is 2. Cos 30 degrees is adjacent. This is the side adjacent to angle 30 degrees, adjacent to the hypotenuse, which is root 3 over 2. And 30 degrees, which is opposite over adjacent. Remember, tangent opposite over adjacent. 1 over root 3. We could take this as the value, but knowing that it's not good for a sort to be in the denominator, we rationalize by multiplying numerator and denominator by the sort. And this is root 3 over root 3. And 1 times root 3 will give us root 3. Root 3 times root 3 is 3. Finally, let's get the sine, cosine, and tangent of angle 45 degrees. This can be derived from a square. Remember that a square is a special right angle that has the 4 sides equal and the diagonals bisect each of the angles, so that a right angle bisected gives you angle 45 degrees. Now, should we have a square of this nature, and one of the diagonals, as I said, will bisect the angle, so that when a right angle is bisected, you have 45 degrees, and should I assign the sides the value 1 units, I can bring this particular triangle out, and I will have a triangle of this nature. Here is 1, here is 1. Here is right angle, here is 45 degrees. To find the hypotenuse, I can make use of Pythagoras theorem. Pythagoras theorem that states the square of the hypotenuse. Let's say this hypotenuse. The square of the hypotenuse is equal to the sum of squares of the other 2 sides, which is h squared is equals to 1 squared plus 1 squared. This will give us 1 plus 1. This will give us 2. And then h itself is the square root of 2. So here is square root of 2. From this, we can find the sine, cosine, and tangent of sine of angle 45 degrees. Sine 45 degrees will give us, this is 45 degrees, right? Very good. Opposite over hypotenuse, 1 over root 2. Remember we said, like we saw here, that a root is not supposed to be in the denominator, so we rationalize by multiplying with root 2, root numerator and denominator. 1 times root 2 will give you root, sorry, 1 times root 2 will give us root 2. Root 2 times root 2 is 2. Keep this aside. Cosine. Cos 45 degrees give us adjacent. Adjacent. 1 over root 2. And just like we had here, multiply here by root 2 over root 2. This would give us 1 times root 2, root 2 times root 2, 2. Tan 45 degrees. Tan 45 is opposite over adjacent, which is 1 over 1. Therefore, tan 45 degrees is equals to 1. So these are the values of special angles using their sine, cosine, and tangent. We have some questions or problems we need to solve. But before that, take note that sine 30 degrees will give you what cos 60 degrees will give you. Observe, cos 60 degrees is 1 over 2, sine 30 degrees is 1 over 2, cos 60 degrees is root 3 over 2, cos 30 degrees is root 3 over 2. So if I should draw a line to connect these, you will see they will give us the same values. And considering special complementary angles, we can also conclude that for complementary angles, what are complementary angles? Angles that sum up to give us 90 degrees. Sine theta is equals to cos 90 degrees minus theta. Cos theta is equals to sine 90 degrees minus theta. Tan theta is equals to, observe something, that tan 60 degrees is root 3 over 1. Tan 30 degrees is 1 over root 3. That is, the reciprocal of tan 60 degrees is tan 30 degrees. So I can also write it this way. Tan theta is equals to 1 over tan 90 degrees minus theta. So take note of this. We'll still make use of it later. Now we are going to solve problems. We have some questions I've written out here, and let's begin with question number 1. Solutions to problems. Number 1. Let's start with number 1. If Pn is perpendicular to QR, if Pn is perpendicular to QR, Pn perpendicular to QR, so they are perpendicular to each other at this point, N. Find the value of tan x. Tan x. What is tan x? Opposite over hypotenuse over adjacent. But we don't know the value from N to R, but we know from Q to R. So what we are to do here now is to get the value here, then subtract it from QR, get Qn, subtract it from QR. That will now give us NR. From that we can find tan x. We have a right angle here. Here is P, here is N, and here is Q. Here is 3. So let's find Qn. What then will be the value of Qn? Remember, still on Pythagoras theorem, 5 squared is equals to 3 squared plus, from here to here, qn squared. 5 squared is 25, 3 squared 9 plus qn squared. 9 comes over here, 25 minus 9 is equals to qn squared. This will give us 16 equals to qn squared. Should the square cross equals it becomes the square root of 16 equals to qn. And so we've succeeded in getting the value of qn. The square root of 16 is 4. That's our qn. And I can now substitute it here, 4. Having gotten here to be 4, then for the triangle given to us over here, I know that here is 4, 3, and here is 5. From here to here is 9. So what are we going to have from N to R? From N to R will then be 9 minus 4. That is 5. And here is X. So to find tan X, remember, tangent of angle is opposite over adjacent. This side is opposite, this is adjacent. So we have 3 over 5. This is your answer. Please take question number 2. Let's take question number 2. In our next session, we're going to answer question number 2, 3 to 8. But before then, I would like you to answer the questions on the board from number 2 to number 8. Then when I come, I will solve it for you. Thank you.